so that that are most realistic and immersive. So going all the way back to my PhD, which was focused on modeling textures. And so, so my PhD, which I did with Catherine Kuchenbecker, focused on doing data-driven modeling of textured surfaces. So using these vibrations that were recorded from when you're dragging a tool across a rough or bumpy surface, and looking at how those vibrations change based on how you're moving the tool, whether you're moving it faster or slower, and how the surface properties of the material changes. And so collecting this data is really challenging. So that the benefit actually of, I'll go back. So the benefit of doing this data-driven modeling is that we can, is that we basically kind of cut out the middleman. So instead of trying to create a physics-based model that is going to then generate the signals, the haptic signals, like the vibrations and forces, instead, in data-driven modeling, we record those vibrations and forces that are generated during the interaction. So we are going to directly record the output of the haptic interaction. And, but recording these, you have the first of all, you have a very expensive recording system, and you have to have a human in the loop. So this work by one of my friends, Joseph Romano, who was also a PhD student with Catherine Kuchenbecker, they tried to have kind of a robot in the loop for recording the data, where they had basically a human holding the tool, but then a drum underneath it to record. But the problem here is you are actually recording the dynamics of the drum as well. Because if you actually listen to the data that was recorded here, you can actually hear the rotation of the drum. And so if you want to record if you want to get data that's actually going to feel like what it's going to feel like to a person, you have to have a human who's recording the data, which is very challenging to do. It's very time intensive. And so during my PhD, I created and released this data set. I think a lot of you probably in the audience might have used it. It's the Pen Haptic Texture Toolkit, which is a set of 100 haptic textures and all of this data. And so it's great. We have all this data available for these 100 textures, but this took a lot of time to create. Months and months and months and months, a lot of time to create just for 100 textures. But these 100 textures does not encapsulate even a very small portion of the textures that are available in the world. So how do we now model textures that don't exist within this data set? So one, we can obviously just record new data. But the problem with recording new data is it's going to be time intensive and it's very expensive, because the recording tool set, we had about $3,000 worth of sensors in that recording tool, so it's very expensive. And physics-based modeling, of course, that's going to be challenging as well, because if you want it to feel like the actual surface, it's very difficult to tune it with just a few parameters, even if you have a person in the loop who is trying to tune it. Because people, I don't know if you've noticed this when running studies, but people are really, really bad at trying to tell you what's wrong with your system. They're just really good at telling you that something's wrong with the system. So having a person helping you to like tune these little parameters and physics-based modeling can be really, really challenging to get it to feel actually like a real surface. So instead, the approach that my student Xihan Liu took is preference-driven tuning, which is instead of having a user have to tell you what is wrong with a prospective virtual surface, they just need to tell you which one they prefer. So it's similar to like going to the optometrist, and the optometrist says, you know, which one is clearer, A or B. So that's kind of what we're doing with the virtual textures. You give them 2 versions of a virtual, or 3 versions of a virtual texture, and you're like, hey, which one do you prefer? So the way we do this is we actually start with the Haptic Texture Toolkit. We start with the 100 textures, and we then we start with the autoaggressive and the friction models within the 100 within the texture toolkit, and then we are going to train a deep convolutional generative adversarial network, a DC GAN, so that we can we're first going to map the latent space to the textures so that we can say, okay, this is what a haptic texture is going to be like. And then we can, we can generate, we basically are going to train this network, and then we can generate new random virtual textures within that are kind of a combination of these different textures within the data set. And so once we have trained the network, then we take, then we want to say, okay, so now we have this network that can just generate, that can just generate an arbitrary number, a infinite number of new virtual textures. But how do I get a virtual texture to feel like this specific real texture? And so that is where the preference-driven tuning comes in. So we start with the latent space, and we do an evolutionary search. So we have, first generate, we choose 3 random points within our latent space, and we generate 3 possible virtual textures. Then the user, which is here, then the user is going to feel those 3 virtual textures. We have it through a voice coil on a 3D Systems touch device. Then the user is going to compare them to the real texture. Then all the user has to say is which one feels closest to the real texture. They don't have to say anything of like, oh, well, this one feels closest in hardness, but this one feels closest in roughness, or, the roughness is too high on this one. They just have to say which one do they prefer, which one is closest. And then that choice is going to update the area of the latent space that we are searching. Then it's going to choose 3 new points that are within that area, within the area of the new latent space, and then we do it again. And we do this until the user tells us that it is identical to, that the virtual texture that we are generating is identical to the real texture. So this is what the system looks like, where this is the user interface, where they are tested with 3 virtual textures that all identically look the same. This is what the user interface looks like, where they have a real texture, which they're touching with a tool that's just similar to a sensible handle, a 3D Systems touch handle. Then they touch the device and then iterate. Now we ran a study to see how well does this actually work. Can this actually replace data-driven modeling, or can it actually reproduce models that are equivalent to the data-driven models? So we tested with these 5 textures, which do not exist in the original database. And so how we tested this is we brought in 2 sets of participants. One set of participants, or one set of 5 participants, just did the modeling, and these are participants with no haptics experience at all. So people who have never worked with textures, have no idea about the terminology of textures, and so have no haptics experience. And so we brought one group of 5 participants to model, and then a second group of 15 participants to determine the realism of those models. So that's why we have that's why we have these 5 preference-driven models here for each of the 5 surfaces. And then here in yellow is what we are going to call the gold standard, which is the data-driven model. And so the majority of these textures were captured very well with the preference-driven model. So what the circles show is that there is no significant difference between the realism of the preference-driven model and the data-driven model. As you can see, the only one that we really struggled at was ABS, which is a really bumpy plastic. And if we dig a little bit deeper into kind of what was causing that, or what is the difference between those preference-driven models and the ABS, is it really comes down to a difference of power. So the frequencies are pretty much the same between the models of the ABS, but what the difference is the difference of power. And so that's something that we do not have within our tuning system right now, is the ability to change kind of the volume of the model, just the overall, just an overall yes or no. And so that's something we might want to add in the future. But what this shows is that it is a very promising method for us to have this way to basically increase our data set without needing to record new data. And it shows that it can be used by anyone, even people without haptics experience. So the next thing I want to talk about is how can we use this data, how can we use machine learning in the data to work on haptic sensing or robotic sensing. And so this is the area of active acoustic sensing. And so what this means is, so if you think about, like, if you have ever, you have two glasses in front of you that look identical, and you need to figure out which one is plastic and which one is glass. So you're going to tap on it to figure out which one is going to sound more hollow or more, hollow, and which one's going to more like ting. And so that's what we mean by kind of the acoustic part of it, is what is the like resonant properties of that object. And so, which is going to allow us, we're going to basically excite the resonant properties of the object so that we can tell the material properties that you could not tell necessarily through visual alone. So similar here, if you basically, what we would do as humans, we would basically tap on the object to be able to tell, like, how full is the glass? Is the glass in contact with the surface? Is it tilted? Am I holding the glass? Now, when we're talking with robots, sorry, the sound's not working, but if we're talking with robots, we can do something very, very similar as well, where we can actually use vibration. So instead of having the robot, say, tap on an object, we can actually instead have the robot inject vibration, like high frequency vibration, into an object, and then look at how that vibration gets distorted as it passes through the object. Then we can train a model to learn what do those distortions mean in terms of the material properties of the object, so that we can learn different contacts as well as the material properties, whether something is hollow or full, or what type of material it is. So we've done this with a Franca Emica arm, where we have a bone conduction we have a bone conduction speaker here, and we have a contact microphone on the other finger. So in our experimental validation, we wanted to tell how can we learn the different material properties? Can we be able to distinguish what are the material properties of these objects, which are difficult to look at visually? So, because this is what they look like visually to the robot. And this is, we can see some are 3D printed, some are ABS, some are solid and hollow aluminum, some are steel and wood. So this would be very difficult for, say, a robot or even a person really to distinguish 100% visually from looking above, and even more complicated for a robot to do, say, in a cluttered environment. So the way we did this is we used machine learning. I won't get into a lot of the math here, but we used machine learning, where we took a bunch of data, where we looked actually at how the vibration, we used kind of a chirp signal, an impulse signal, and a chirp signal and impulse signal to look at how that signal gets distorted as it passes through the object. Now we can determine not only the material properties, but also where the contact is made along the object. And so here's the results of this, where we can actually see this is the confusion matrix of which material property it is. We have very, very high accuracy. And this is where we're able to determine the location of the contact as well. So we're only have an error of a couple of millimeters being able to determine where the contact location of the on the different objects are. So ideally, it would be perfectly along the diagonal. And so this is really, really promising for us to be able to use this for robot manipulation and in cluttered environments. So I unfortunately am out of time. I was hoping to get to social touch, but I am out of time. So apologies for that. Hopefully people went to my talk this morning, but I'm happy to take any questions.
How many iterations of the evolutionary algorithm did you need to get to those results? Do you have a stopping criteria? Just
very good question. So there was no stopping criteria. The stopping criteria was the person. So the person's own internal, go until it feels indistinguishable or correct. It took only about 5 minutes. On average, it was about 5 minutes, somewhere between 7 to 8 iterations. So very short amount of time, especially for people who have no haptics experience.
Hello all together. I am very happy to be here, and it is one of the hot topics. Thank you very much for this great organization and invitation. And I think that in very soon, a lot of companies will need AI-based haptic technologies, and we should deliver some fundamental knowledge. Unfortunately, it was same also for actuators and sensors. Most of us know that suddenly we should deliver some pragmatic solutions. I hope very much that in this case, we can create some fundamental knowledge and deliver it. And therefore, this discussion today very important. And although we have a lot of competitive workshops, I see that so many experts are here. Today, I have great plan. I hope that in 20 minutes I can realize it. I will strongly concentrate on labeling in different domains, and then also talk shortly on gesture recognition and also signal analysis. In Dresden, as Orestes visited us 2008, we started to conduct research with different PIs in these excellent clusters. Center for Tactile Internet, Human in the Loop. The main idea was that if we develop new kind of solutions for tactile internet, for AI, we need also research on communication technologies, because our cloud solutions or relevant solutions should be realized also for haptic domain. And I hope very much that today I can shortly present some recent results on it. If we are talking about AI, mostly we try to mimic human. And if I look here, I can recognize different persons. I know some of the names. I know who are, and your clothes and different colors and so on. All this information, I can analyze it. And we hope that, of course, AI can do also similar way. It means that main idea based on data labeling, based on photographs, videos, or audio. We are already very successful on this domain. Also, we transport it in audio case, which was also on the first talk, important topic, because of course, audio is based on the already language, and the language is the best methodology behind of the AI. And the main idea is, again, is the labeling. if we are talking about haptics, we have great difficulties in comparison to visual and auditory domain. The main aspect is that we don't have one haptic device, sensor, which functions for everything, and one actuator, which functions also everything. It means that we have several different dimensions, which we talk today, from the surface texture to vibration, force or weight, but also form, size, softness, material perception, temperature, whole body vibration, and motion. It means that we are talking very different spaces. We are talking about very different sensors which deliver this information, but also actuators. Therefore, today I will concentrate on haptic labeling, because not only is enough to know that it is a force, it is vibration, or it is texture, or it is whole body vibration. We need more information for the labeling, and therefore we need some fundamentals for the haptic domain. Haptic labeling is somehow missing, and we deliver altogether knowledge for it. And this will be used possibly by the companies. I will start with vibrotactile perception and go farther. This is a actually picture from the children book, school book in Germany from the third class. And you can easily notice that already as a child, we can easily label different sounds. We can easily label also visual information, but also vibrations. Although we think that vibration perception is very limited, we can get a lot of information using the vibration or haptic information. Therefore, we try to conduct several investigations, which I will not deeply explain it. If there are some questions, I will talk on it to understand which kind of verbs we use or which kind of adjectives we use to describe haptic events. And of course, you should be careful, because each person can use different terms which cannot be understood by others. Therefore, you should make some suitability check, but also understandability check and so on. If you do it in a free verbalization interview and further aspects, then at the end, you get a space for haptic event. I will talk today, first of all, about whole body vibrations. If we get, for example, whole body vibrations in car or in different aspects, we perceive it. We have conducted similar kind of research, and we could identify that different frequencies will be perceived very differently by us. Not maybe as sensitive as auditory perception, but it is possible to differentiate it. And we try to describe in different words like rumbling, like humming, or shaky, bumpy, and depending on the impulses, depending on the amplitude modulation or frequency modulation, of course, some other terms came in, like wavy, to describe this kind of events. Of course, emotional terms are not inside of it, not only signal-based terms, but we try to improve it, of course, using also emotional terms. And the main idea is that we always think, as a haptic researcher, we should record as much as possibly best physical way haptic events and reproduce it in a best way in physical domain. But this is also an important question. What is the realism? What is the virtual reality? What is realism? And we noticed that in most cases, we don't need to be authentic as normal life. In most cases, it is enough to fulfill the expectations. It means that plausibility. And plausibility is very different from the authenticity. And in that case, it is very critical to know that what we expect from this haptic event, haptic reproduction. And therefore, we try to develop a labeling model which can be used for the synthesis, because in most cases, of course, if you drive a car in a different conditions, you get different kind of vibrations, which you can describe it. We have conducted also some research to understand which expectations you have if you see only the visual scene, and which kind of vibrations should be reproduced. And in that case, you can easily notice that you shouldn't be exactly same as physical domain, same frequencies. You can shift the frequencies if your actuator is not able to reproduce, for example, 20 hertz. It is possible to shift it to other frequencies if the expectations are fulfilled. It means that the labeling can function. And therefore, we try to develop some models based on, of course, signal parameters and based on expectations to deliver this synthesis to the reproduced systems. And of course, this is the data in the laboratory, but in most cases, reproduced data was very successful to make actually users happy. And it can be used for different aims. But at the same time, the critical issue is in haptic domain, in comparison also to the auditory domain, is inter-individual differences. It means that already if you look at perception thresholds, you have more than 20 decibel differences between the person. And if we think about the age, of course, we know that if you will be older, you lose, of course, at high frequencies, your capabilities. It means that the adaptability is quite important if we should develop some reproduction systems which are based on AI. They should be able to understand what are your, first of all, haptical aspects and deliver depending information using this information. And at the same time, what we know from the auditory research is that expectation of the different customer groups can differ also. It means that if you go to the direction, emotional aspects or quality, you should also take care about these groups. It means that depending of the social status, it plays strong role what you can buy and what kind of experience you have. If you drive only very high level cars because you are rich, of course, your expectation is quite different if you should drive always very bad cars and with bad vibrations. It is similar also for all different devices. It means that your expectations is based on, of course, your cultural level, but also on your social status. And in most cases, of course, there are adaptive achievers which try new products, make experience and explain that this is great, then these products will be cheaper, and then middle group buys and get experience and change also depending experiences. This is also a very critical issue if we develop some systems. The AI system should take into account this information. I will go very shortly about also textures. Textures are quite interesting object. As you explained that there are incredible number of textures which we interact in daily life, and they have strong differences on it. There are some investigations to understand main domains. First of all, hardness, of course, friction, warmness, and roughness. We try to understand also if we can define the dimensions in better way. And in our research, we noticed that if we want to describe this touch perception on textiles, for example, we should concentrate on softness, smoothness, warmness, but elasticity. If the structure is even or structured, fluffy or stretchy or slippery and sticky. This is only the first point. After that, of course, they include also several different labels inside of them to understand the perception of textures and reproduce it in a synthesis domain. Therefore, we try to implement in a similar way that which frequencies, which connections are existing in signal domain to this perceptual labeling to reproduce it. And the main issue is that if we think about our smartphones, we have very cheap, actually low quality cameras, but they deliver very good results. Of course, it is not already comparable with this kind of cameras, which are very expensive and have, of course, a very high quality camera. But at the same time, the comparison is already available because of AI, because of signal processing. And this gives us a great opportunity as haptic researcher, because it means that we can use cheap sensors for haptics or actuators, but using AI and also using for signal processing, it will be possible to get information which we need and also deliver information which we reproduce, of course, with some limitations, which is existing also for these cameras. And very critical issue is our aspect is the delay or latency. In most cases, our hardware has already very long latencies if we don't account the communication channel. And already if you see at 10 millisecond delay between the communication, we have great problems in haptic systems. And this means that we should find solutions. We try to develop some hardware which has lower delay, but it is not so easy as it is if we develop some haptic systems or robotics. You know it very well. And for a lot of applications, from the training for also medical applications, these kind of delays are very critical, because you cannot allow more than 10 millisecond or more than 20 millisecond delay will happen in this kind of interaction. And therefore, one of the idea is that before already interaction happens, if we can recognize the gesture, then we can reproduce the signal beforehand. It means that some kind of negative latency to understand the actually intention of the user. And therefore, we develop some different sensor systems to understand the movement or gestures, and therefore deliver the signals beforehand. And this is also an interesting domain for social affective touch, because in that case also the time can play a very strong role if you interact. My PhD student gives also a talk at the same time in other workshop. We try to understand also for social affective touch, this kind of labeling and reproducing the information. I hope that time is okay. Rapid integration of AI to haptic applications is necessary, and therefore we researchers should deliver good knowledge on it. More fundamental research is necessary, and labeling is one of the important topics which I would like to focus on, and haptic dimensions. As I already said, that gesture recognition and adaptive feedback will give us great opportunities to adapt our haptic solutions to real daily life applications. Thank you very much for
lecture. Thank you very much. Can you elaborate a bit more about this, how to use AI to create cheap haptics? That part sounds very intriguing, but I didn't get it.
Actually, if you know exactly the expectation very well by the user, then your AI model is trained for it. Therefore, it needs some time to make training. There are also unsupervised systems which we use. And if I discuss with Metaverse, they say also unsupervised systems are much more better, because you can get easily, without big amount of data, directly usable AI. But at the same time, my experience is that some haptic knowledge and supervised system deliver better results. And we train first of all and try to understand expectation based on this labeling. And then if we understood it, then we try to reproduce how we can deliver this perception using the signal properties. It means that AI system at the end deliver the system properties to synthesize the haptic signal. But this should be now realized for individual systems. It means that because there are also labeling for air-based ultrasonic haptic information, if you compare with vibrotactile systems, and there's a big differences for the expectation, but also what you can reproduce. therefore, it is somehow not a universal model which you can apply for everything. You should always, first of all, develop the AI model for individual system actuator sensor system.
Yeah, there is huge differences also in the brain.
Absolutely.
Haggard can say
Absolutely.
the air systems and
Absolutely. Therefore, I'm very happy that the next talks will go inside of.
So let's take some
I'm the next.
video again. Yeah, yeah. So our next speaker is more about audio and haptics. And he's a specialist of the brain. So you will have a presentation by Amir Amedi. We can I think welcome him a bit.
Okay, so it's a great pleasure to be here. There is probably these very short lectures. I would never get into speaking into what I plan to speak, so I will try to give a 3 minutes overview of the lecture and also invite you for a demo that Gizem Otzvir, which is a PhD student in the lab, would have here, so you can experience what we are talking about. So the main part of the lecture, I will try to deal with the interaction between haptics and auditions, and mainly from the perspective of auditory impairment. There is a huge epidemic in the world of increasing people with hearing impairment. And as part of our work, we found that people with hearing impairment, cochlear implant users, hearing aids, and so on and so forth, are almost completely a chance in localizing sounds in space. Even in the best dimension, which is our horizontal dimension, not to mention other dimensions of the sound space. We also replicated other works showing they are extremely impaired in auditory speech perception. When there is noise, they cannot recognize music or very hampered with this. And we wonder whether haptics can be useful to them. Okay, so the first technology we developed was a touch interface that capture in real time the richness of all the frequencies in the auditory space and the relationship between the frequencies and the phase, and transfer it into touch. So basically, all we do is, we have the frequency width of touch, which is lower frequency, a little bit of overlap, and then the audition. So we capture all the frequency on a online version and then transform it and shift them in the frequency domain and time domain into touch. And when we do it, quite surprisingly, based on other work I did before in trying to teach blind people to see using sound, a little bit like bats and dolphins, which requires a lot of training, we found that almost immediately they improved dramatically in their auditory perception. So 10 dB increase in speech, in noise. So it's almost doubling the signal to noise in less than 1 hour. In the localization domain, it was even more dramatic. So basically, they go from almost completely normal, random, to very close to the performance abilities of hearing people. Again, in a few minutes of training. So that was and then we can introduce the AI part of the talk. We then try to think practically how to implement it in the real world, and we realized that in order for this device to work, we also need to know in a regular ecological place like this, where the sounds come from, yeah? In the lab, in our ambisonic room, we can program the sounds and test them. But now, if somebody's speaking, I need to know where the sounds come from. And we turn into AI models that model the localization. And to our surprise, the standard of the models used a method which is basically using multiple microphone arrays. And then when sound came from different location, the different microphone have different characteristics, and they managed to reach about 20 degrees of separation, which is not that great. So that was the state of the art. And we said, okay, and I think this is one of the messages I want to introduce here. we said, okay, why don't we use a model that is based on how we do this in the brain? And the way we do localization in the brain, for those of you who are not coming from this background, and sorry, Patrick, for these trivial things, if you close your eyes, for example, try to point to where I'm clicking with my finger, okay? Let's see how you're, we'll do actually 5 trials, and let's see how are you doing. So all of you need to close the eyes and point. It's, yeah, I'm a university professor. It's not great. So you were very good at the horizontal, and when I went into lower and upper, you were much less good. And if I would do in the back, you'd be even worse. And the way you do it is by 2 main computational algorithms. And it's different for low frequency and high, but I will do it very quickly. It's basically either looking at the differences of time between the one ear and the other. So if it's here, it will come to 2 ears in the same time, yeah? And also, or it can use different amplitude, and we also use different phases. And we introduce this to the model of the AI, and basically we managed to jump from 20 degrees to less than 1 degree in the performance of the system. So this shows how effective this dialogue between neuroscience and technology and AI. Next stage, we created the same algorithm. We tested them on people that are not hearing impaired to see whether they could use it as efficiently or not. And we found that they are. Okay, so blindfolded sighted people that use it can decode location in 360 space and in any movements. Almost as good, a little bit less, significantly less, but really a little less than the capability of the auditory system. Then we implemented it into VR, okay? So that was one part. The second part of the talk, we ask, and it's very interesting, the morning session on emotions and haptics, we ask whether we could use higher level of sound and not just localization. For example, can we improve the enjoyment of music? So first of all, we created an algorithm that make music accessible to cochlear implant patients. And this was one project. And then we ask what happens in where people that are not hearing impaired experience music together with the body. So for example, let's say I'm doing some kind of meditation, or I'm choosing a music that is usually used to be relaxed for me. And I'm have anxiety, like now I'm a bit anxious because this improvisation of doing all the talk without the slide in 5 minutes is not working that great. It's taking longer, but never mind. And let's say I'm feeling anxious here. So if I'm going to take the music and put it here, would I feel more relaxed when I do it this way, or enjoy more the music? I've increased enjoyment, yeah, or positive feelings, and we have the scales to valence and so on and so forth. And the result is that it is. So if I'm giving you the same song just by audition or with touch, and you have much more positive valence than just the sound. And now we're using different clinical trials with people with anxiety, depression, post-trauma. Unfortunately, in the region, we are not short of this. Yeah, but we won't get into this because then I would finish all my 20 minutes. So that's another part of the talk. And the last part of the talk, we basically ask how the brain learns such things, how it transforms information, and we couple all this technology, we make them MRI compatible and ask different questions about neuroscience, which maybe I have time to get, but probably not. Okay, so this is in a nutshell. Did I forget anything, Giselle? Okay, so this is in a nutshell what I plan to. How much time do I have now?
10 minutes.
10 minutes, great. So, and by the way, this is a relatively new topic to the lab. Last 4 years, we did other things. So some of it is already published. If something interesting to you, for example, the localization studies was just accepted this month, and I would be happy to share. Okay, so these slides basically shows a lot of time how we used to think about projects in the lab. For example, our previous work worked on dolphins or bats, and you know the saying, blind as a bat, yeah, but it's wrong. Bats can see very well, yeah. They just have two systems to make them advantageous evolutionary, yeah, because if it's light, they can use the eyes. If it's dark, or they go into the cave, they can use complex sounds. And then we ask whether we can develop similar technology to help blind people see better, yeah. So also in the case of sound and haptics, there is something like this. So for example, elephants have two sound systems, yeah. One is for short distances, just like us, but sound is decreased with the square root of the distance. So in 100 meters, nobody can understand what I'm saying. I hope that from 10 meters, you can understand what I'm saying, yeah? And but infrasounds, which are much lower frequency, just like radio wave, can travel for kilometers, and they have mechanoreceptors in their feet, and they can interact with each other from over a kilometer distance, yeah? And they even can lift one leg and do triangulation and do localization very nicely with this. So we said, okay, let's try to create this haptic system. I probably won't have time to talk at all about neuroscience, but I want to say it's very emotional for me because my first PhD studies were actually on haptics, yeah? So I tried to see what happened when I'm doing texture analysis versus object analysis with touch. And I expected to get the activity in the homunculus and the areas in the touch system, the division of Library. To our great surprise, we found that the peak selectivity for object recognition was in ventral stream in high order areas that are homolog to IT. And when we do the texture, we get early visual, which looked like really bizarre. So we did all sorts of controls like mental imagery and so on. And this is how I got to start working with blind and deaf, because we ask what happened when people that never had visual experience. Also, the peak is in the same areas. And then we come up with this idea that actually maybe the brain is not organizing primarily through the senses, okay? Mainly there is a computation to be accomplished, and I think it fits very nicely with AI and machine learning models. So in this case, we argue that this part that we used to think is visual is doing geometry analysis. And usually vision is the best to do geometry, but touch also good, at least for short distances. And when we teach people at the age of 50, 60 to do geometry based on sound, they recruit the same areas. So this is one word about neuroscience, but now let's do very quickly the present some of the data, so you can, it's not just stories, yeah? So first of all, if we think about the cochlea, it's basically a two-dimensional structure that have all the frequency organized according to the frequency. So we created this artificial 2D touch interface with two fingers that can vibrate all the way up to 600, 700 hertz. So from very low frequency to the highest frequency possible for touch. And basically we created, as I said, this algorithm that take all, if there is a lot of low, so the power, the combination of the frequency and the power, and change them every time window very rapidly. And we just shifted it to the touch. And then we get this, this very nice results, that there is a 6 dB immediate improvement and 10 dB improvement after less than 1 hour of speech understanding in noisy environment. Yeah, so that's a work by Kasia Chesla in the work, Dr. Kasia Chesla. Then together with Dr. Adi Snir, Gizem, and Rotem Wexler, we use this very unique setup of ambisonic room. So basically, it's a room that doesn't have a lot of reverb, and we can create a very, very accurate 360 model of the sound in less than 1 degree of angle. So very, very accurate. We also have in-ear microphones, so we can record in the exact same person and replay it in the MRI, and we can test it. So the first thing we did was to test cochlear implant individuals. So we ran two main experiments here. The first experiment was in the horizontal plane. As I said, this is the most efficient plane of localization in humans. And we basically we get a sound coming from a given point, and you need to point to it, and we compute the difference. So if it's a 1, it means you didn't have even 1 degree of mistake. If you are completely random, you 0.5. And if you are anti-correlated, so if it's coming from the right, you say left, or coming from here, you say here, it's 0. Okay. So first we tested it with audio, then audio and tactile. So audio is the regular from the subsonic, from the speaker, tactile from our system, this monocular, this stereo system that basically do the same of what we did with the mono, but now also adding this time, amplitude, exactly what I discussed in the intro, and some other tricks like Doppler, and I won't get into all the details. Then we have only touch. So we try to localize location, but only on this touch system. And then we wanted to see whether we can improve the baseline abilities of the auditory system. So this is very important, for example, for cochlear implant. Can we make them better than what they entered the experiment? Yeah. And then we did it again, an experiment in 3-dimensional space. So in this case, it was not just horizontal, and the results are here. And I think they are very, very promising in terms of the haptic worlds. Okay, because I think there was no such a thing so far. What you see here is people without hearing impairment. Yeah. So you can see here the performance in audio. There is variability, of course, but people are fairly good. They're actually not perfect. Some people are close to perfect, close to 1, but some people are around 0.8. So they have some deviation in the localization. When they try to do it only with the tactile, it's not that far. Okay, so this is without training. There is no training involved. For us, it was a big surprise. Maybe it's because of evolutionary reasons, because it seems that the auditory system developed from the touch system. It's a very interesting story. I won't get into it, reptiles and later, but it's very interesting. And when we combine it with touch, they assign the touch exactly to the same location. Okay. Unfortunately, after this 1 hour experience, there is no improvement in the abilities of the auditory system. Okay, so we cannot make you super hearing with this, but now we run more longitudinal studies on them. And this is a very interesting slide. Once we add noise into to the system, so this is the localization performance without noise, and this is if we add, for example, pink noise or other sounds and so on, we drop. And then if we add the touch, we are actually improving again. So you know the situation, you go to a restaurant, especially when, like me, when I'm getting older, it's more and more difficult to understand. It's noisy. Now I add the touch, I'm doing better. And I think this is the most exciting slide, or the second most. This is what happened in people that are cochlear implant users, yeah, or hearing aids. They're almost a chance, a little bit above. They're better than chance, but very close to this 0.5 chance level. But you add to them the touch, they become almost as good as hearing. And they combine the touch with their very bad hearing. Again, also here, 1 hour of experience is not enough to improve your auditory system. So now we teamed up with various cochlear implant center. Actually, it's very surprising when we did this study. No one is doing auditory localization rehab. They do a lot of speech rehab for a year. This is people we got after 1 year of rehab after the surgery and 10 years on average of experience with the real world. And they cannot localize anything. So they go, they drive, and they have license. They don't know where the cars and the sounds come from. Yeah. So, or they walk on the street and some bike come and they don't know where they come from. And this is maybe the most dramatic slide. This works in an individual level. All of the cochlear implant or combination of hearing aid and cochlear implant or 2 hearing aids, all of them are almost at random. They add the haptic stereo system. They almost become much better, and they combine it with the regular auditory space. And as I said, this was the basis to develop this AI-based system. I would skip the movie. If you want, I would be happy to share you a clip of a TV series of twins that were born deaf and come to experience this and all the localization, enjoying music and so on and so forth. Also, Gizem can show it to you. And I would finish with this is one slide that just showed this enhanced, all this rehab of post-traumatic and anxious and so on, saying the improvement enjoyment and better balance with the combination of haptic and touch. And I want to finish with this, since it's an AI, with this work and directly to this paper that we just published recently, that basically showing that maybe this is, I will show just one slide here, and I think I need to finish, right? That's my time is up. Okay, so I will just finish with this. I think, yeah, these slides is that if we are taking the regular system that used a very complex multiple array of microphone to create a training set for the AI and do localization of sound, we are getting around 20 degrees of separation, 90 degrees. But if we are using this head transfer model function based of algorithm, and now doing the recording and the training, the generalization jump into about 1 degree or less. So again, this is how efficient it could be to integrate neuroscience, technology, and AI. I don't do that much work in AI, so I try to grab what is relevant. So thank you very much.
Was a coffee break after this?
Oh,
Finished it.
Yeah. So give them all, we'll have it also here for the break and also for the conference if you're interested.
Yes.
It's a very simple demo of choosing your favorite song or using a meditation-based audio and combine it with haptics, whatever you want on your body, hands or everywhere. So that you can feel it.
No internet.
It's a real thing.
Thank you.
Sure.
But before the break, we are going to have a last presentation, if it's okay.
We're trying to connect.
Yes. So Patrick Haggard is going to talk about ethics for AI in a few seconds. And then we will have the short break and you can try the demo, take a coffee, wait a bit.
Sorry for the short delay. Thank you very much. It's a pleasure to be here. I'm going to be talking about ethics of digital touch, which is only slightly related to AI, but I've tried to bring in an element of that. This is work that's been done in the context of the Touchless project. Okay, I'm going to try and do just 4 things. I'm going to give you a bit of overall context for the ethics of digital touch. I'm going to try to introduce a key new concept. So the one take-home message, sensory autonomy. That's the thing to remember. I'm going to quickly at the end go through a list of some of the ethical concerns that I think we have with new digital touch systems and end with 5 questions that you can each ask about your own use cases. So it's a little bit tutorial, if you like. So first of all, it's important to distinguish between risk management and ethics. So most of you probably have to get university ethics committees or company ethics committees to approve your studies. And these are organs that do risk management. They don't do ethics. What they really do is stop people from suing the university when something goes wrong. So that's very useful. It's very important. We have to do it, but it's risk management. And ethics is not that. Ethics is the process of analyzing whether something is good or bad and why it's good or bad. And ethics is therefore an important way of understanding what we're doing and what its sort of moral status is. Now, I don't need to tell you that technology has a history of lots of unintended adverse consequences. We don't know what the consequences of future tech developments are going to be, but it's useful to think about it. I'll just give you a little example. So the first sort of ethics type committee that I ever did was a UK government advisory group on non-ionizing radiation. And the question here was, do mobile phones fry your brain? So we're talking about 15 years ago. There was a lot of concern that the RF EMF would somehow interfere with brain activity. We had this big government committee. It went on for lots and lots of meetings. And eventually it was concluded that probably there's no actual direct effect on the brain as long as the mobile phone doesn't heat the brain up. And now, this is the headline from The Guardian a month ago, MPs urge under 16s UK smartphone ban. Now, clearly an unintended and possibly ethically problematic consequence of smartphones, but completely different from the one that I spent several months sitting in UK government committee rooms to deal with, right? So you don't know exactly where the risks are going to come with new tech. Now, what this means is that if you take an evidence-based ethics approach, it's very good, you're necessarily being retrospective. You're waiting until the tech produces a problem and then you consider the ethics of the problem. And the alternative is to take a principle-based ethics approach where you can try to shape tech development based on upstream thinking about what are the ethical hazards in this particular situation. Now, this is the only slide about AI, and you can see that I quite like The Guardian. It's the one good remaining newspaper in the UK. And this is something that they had yesterday. Ray Kurzweil, father of AI in some ways, was giving an interview. And I just extracted a few of the things that he said about the AI-based future. Making it possible will be brain-computer interfaces, which ultimately will be nanobots the size of molecules that will go non-invasively into our brains through the capillaries, blah, blah, blah. Question, what should we be doing now to best prepare for the future? It's not going to be us versus AI. AI is going inside ourselves. So I just thought it was really interesting that in his fairly interesting vision of the future, there is a direct tactile interface between AI and the human physiology. So this means that haptics is an area where AI is going to have significant ethical implications. Right, what is sensory autonomy? Sensory autonomy is the right to control your sensory inputs. People have a right to control their sensory inputs. I don't like horror films. I close my eyes. I have a right to do that. I don't like your music. I put plugs in my ears, or I put on my noise cancelling headphones with the music that I like. I don't like the smell of your cooking. That's a little bit harder. And actually what you probably do is you probably move to a new apartment. So many of the things that we really hold as important human rights are actually ways that we exercise our sensory autonomy. So freedom of movement, which is an absolutely fundamental principle of human rights, really is a freedom to choose what sensory inputs you want. And I think this is a really important point in modern society. We need to make sure that we control our individual sensory inputs. And this is, of course, a massive problem for skin sensation and particularly touch, because touch is always on. You cannot switch off your skin in the same way that you can close your eyes or plug your ears or hold your nose. So our sense of touch follows us around, which means that any tactile stimulator potentially challenges our sensory autonomy. So any device which is used for tactile stimulation and is in contact with the body is potentially not necessarily a violation, but a challenge to our ability to choose what sort of inputs we want. So we can look at different sorts of existing haptic technologies, and we can ask, to what extent do they compromise our sensory autonomy? So haptic-enabled controllers, probably not very much, because you can just take your hands off the controls. Wearable interfaces, smartwatches, well, perhaps a little bit more, because you are continually, in principle, exposed to haptics, to tactile stimulation. And body-worn haptic vest type devices, I think, potentially have fairly severe implications for sensory autonomy. Now, in terms of haptics, I think there's a really important distinction that follows from this. We can distinguish in tactile neuroscience between active touch and passive touch. Active touch is the processing of tactile signals that I get as I move and which I use to explore the world around me. So if I use my hand, I can tell the difference between the coins that I have in my pocket without looking, simply by using active touch. And in cases of active touch, it seems to me that the sensory autonomy challenge is not a big problem, because you opt in, you move towards the world, you go and feel the texture of the fabric for the different clothes that you're interested in buying on the rack in the closed shop, and your actions are basically asking for tactile sensations. So you're exercising your autonomy in a positive way to get particular tactile sensations in active touch. And I think that's not really a great ethical problem. That's probably actually a good thing. It's a little bit like choosing what kind of music you hear when you put on your headphones. The big problem is passive touch. The big problem is passive touch, because in a passive touch system, does the user really want the tactile stimulation that they're getting? Are you really respecting the sensory autonomy that we assume that users to have? There are some really simple ways of dealing with this. By far the most obvious is that the user should have an off switch, or they should be able to take the device off. Maybe I'm just old, but I think it's really important to state the obvious. Really, really useful to state the obvious. And I think in future haptic interfaces, the provision of a user off switch is going to be really, really important. I think the other thing which is important is to carefully negotiate and contract what touches are acceptable. So the user needs to know, for example, when they put on a watch or a vest, they need to know what kind of stimuli they are ceding their autonomy to somebody else for. Okay, what do you agree to accept these kinds of touches? And that's particularly important for haptic interfaces, which you can't easily remove. Okay, so I'm just going to rattle through now some of the main ethical concerns that we've identified for modern haptics in a recent paper, and I'll give you the coordinates of the paper at the end. So sensory autonomy is the main one, which I've already talked about. There are a few other things which I think are really important to remember in ethics of digital touch. The first one is transparency. So who is actually controlling the tactile stimuli that the user is getting? Are the touches being controlled by another person? Are they being controlled by an algorithm? Who is the other person? Who controls the algorithm? Are they perhaps delayed playback from your own previous actions? Who is touching whom and why? These are really, really important questions, which I think we can all understand that just in terms of sort of personal identity, we need to know. This is an interesting one. So we know that the brain maintains a sense of self, and the sense of self that we have, our sort of individual self-consciousness, is deeply linked to our body, and it's deeply linked to the sentience of our body. Now, tactile stimuli are on the body by definition, and they potentially change, influence, alter the way the body feels. So this is a concern. You may have heard of body dysmorphia. This is just an example of a recent news item on body dysmorphia. There's a lot of difficult, some social, some more neuroscientific concerns around how we think about our own bodies. When you have tactile interfaces, you're right in there. You're exactly doing that. And it seems to me very likely that future haptic interfaces will directly manipulate the experience we have of our own bodies, and that produces risks because one can have distorted experiences of one's own body, which may be problematic. This is another really interesting one. So reality testing and epistemic risk. This is not here yet, but it's perhaps coming, and it's perhaps quite interesting. Touch is the ultimate arbiter of physical reality. There's an interesting example of the 18th century philosopher who said that nothing exists, that everything is just an illusion. There are no physical objects, there's no physical world. And Dr. Johnson, who was a wit of the 18th century, kicked a stone and said, "Thus I refute him." So the physical contact with the stone is enough evidence that there are physical objects. We know about our physical world, and we know about our real environment primarily through touch. This is a beautiful painting by Caravaggio in which Thomas places his finger into the wounds in Jesus's side, and that's when he believes that Jesus is real, right? So it seems to me that future tactile interfaces can possibly produce a level of deception about the objects in the physical world, which could potentially be powerful. At the moment, it's not. At the moment, it's some interesting illusions that neuroscientists like to work on. But for example, imagine a future haptic interface in which you attempt to clap your hands. You move one hand against another and you don't feel anything. So you can engineer haptic interfaces in which your own body seems to become unreal or disappear. That's a fundamental challenge to your sense of reality. It's an epistemic risk. So I think there are going to be some interesting questions about deception. haptic deception and what do we do about it? Is it ethically acceptable? So just to end, we've got a list of 5 questions which we think are worth asking about any digital touch project. Is your project active or passive touch? Which skin regions are you touching? Because there's a big difference between touching somebody on the hands and touching them somewhere else. Is it clear to the user who's controlling the tactile input? Has the user got an off switch? Those are really obvious ones. Here's the important one. Have you thought about the ethics of what you're doing? Right? This is not the same as have you got ethical permission from your university to do this experiment? Have you thought about the ethics of what you're doing? It's in the Touchless project, we've had several rounds of really good discussion using the EU's Responsible Research and Innovation Toolkit, which is a way of helping you to think about future ethical implications of current innovation. There's a link there, and it's just an extremely interesting process, not just for ethical reassurance, but it tends to have big scientific benefits as well, because you think more clearly about the reality of your project. So thank you very much for your attention. Thank you all of these people. There's a preprint, which is unfortunately still in review, not yet out, of the paper underlying this work. And there's a flyer, which is a sort of takeaway paper thing, which gives the summary and which is available for distribution from me right now. Thank you very much for your attention.
You can touch the fly.
I did. It felt safe.
That's it. That's it. So thank you. We have time for some questions.
Hey, hi. I really enjoyed the talk, and it's very important and stimulating. The question about the reality and touch, like I found it fascinating. On one hand, we have this saying that you pinch yourself.
Exactly.
Yeah, but on the other hand, we have the rubber hand illusion where actually the vision is the one that tells you actually tricks you to believe the rest. So
Yeah,
any
vision
thoughts
often.
about,
Yeah, it's a good question. Vision often wins. That's certainly true. I think we're quite used to visual deceptions. So we've become culturally quite used to things like cinema. So we see images on the screen and we know that it's just an image on the screen. We can get something out of it. It's become something extremely useful. But I think that there would be concerns, particularly if you were able to produce tactile devices, which I think I'm particularly worried about the idea that you could make yourself disappear. I think self-touch is a very, very important part of mental health and self-consciousness. And I can see forthcoming haptic technologies which could interfere with that fundamental sense of self-consciousness. So I think that was the reason why I'm worried about tactile deepfake.
yeah, it's basically the same sides. It's on one hand, there is a huge potential for mental health. On the other hand, because of this potential, it's so risky for general use.
Exactly,
maybe.
exactly. And I think the process of thinking through, for example, how do we prevent unintended uses or unfortunate misinterpretations of what we're trying to do is very useful scientifically. Thank you. Hello.
Okay, last one. So you thought about the ethics of being touched without knowing. So if, for example, you can turn off your button of feeling the touch, but imagine that you're in a VR environment and human communication. You don't feel anything, but the other person can touch you and feel you. And I think that might be a big ethical problem. So what do you think about it?
Well, that's a really interesting question. I think the person who is pressed the off switch is not getting touched, so we can forget about them.
Yeah.
The other person thinks that they're, I don't know, stroking your hair or thinks that they're interacting with you, and they're getting haptic feedback consistent with that, but they're actually not interacting with you. They're just interacting with the machine. So that then would constitute a tactile deception or tactile illusion or tactile simulation. And you'd have to look very carefully at whether you thought it was ethically acceptable or not, and why. So there is a section in the paper on communication scenarios where you have two people touching each other via a haptic interface, which deals, I think, with a little bit with that question. Yeah, thank you. Yes.
if I quickly add, I have run dozens of VR experiments with VR headsets, and I noticed, and I quickly started to do this, that if I need to like adjust something and user is using VR headset, I always tell them, hey, by the way, I'm going to touch your hand, I'm going to touch your head. I warn them. I have seen so many people's kind of just starting to touch people who are VR headset, and I've almost accidentally hit my wife. She touched me when I was using it.
Because the person wearing the headset is in a particular space and their motor reactions to any skin input are going to be unusual. Yeah.
Yes. Can we say that it's all about consent? So if we say in advance, look, this device is going to be this, and that. If you agree, great. If you don't, then you don't use it.
Yeah, that's a great question. So consent is really important, and we do quite carefully transact consent when we interact with other people in lots and lots of situations. So people ought to say to you, excuse me, do you mind if I quickly use my phone? They don't often say that, but they should. So we should transact consent when we impinge on the sensory receptors of another person. So the problem is it's quite difficult to do that. So transacting consent is not straightforward, and consenting to one thing does not mean consenting to another. So consent for these kinds of particularly immersive experience is going to need to be continually tracked and continually consented. And with each new alteration of normal experience, I think people are going to need to be reassured and to reconsent to what happens. So is consent enough? Well, maybe there are some things that we shouldn't do even if the person consents. So consent is not a magic trick. But I think the problem more is that we tend to get people to sign the form or click the box saying they accept the terms and conditions. And that's probably not going to be enough, given the power of some of the experiences that we are likely to be able to generate through haptics in the next few years.
So let's move on with the next part of the workshop. So now we'll have a presentation from Marianna Obrist from UCL. So she is joining online. Hi, Marianna. And so since we have, the audio is coming directly from the laptop, so let's try to be quiet. It should work well. So we
try to be loud as well. Okay, thanks so much for inviting me, and I'm really sorry for not being there in person with you. And right now, I'm really feeling sensory deprived because I'm actually shouting towards a screen. I don't see anyone, I don't hear anyone, and I can definitely not shake anyone's hand. But I hope that you can follow me through the next few 19 minutes. Oh, thanks very much. There's some visual. I can see you now if you're texting. Don't worry. So I'm going to hopefully give you a little bit of a flavor of my research on multisensory interfaces. And it's not particularly on AI, although I tried to put in that twist in my slides as well. But what I really hope to achieve is to give you a bit of a different perspective, like zooming out from touch and taking into consideration other sensory modalities, and then raise a few questions that hopefully link back to what we have heard before, and particularly I think what Patrick also said. I think there are some really interesting overlaps for the later discussion. So as Claudia said, I'm from UCL Computer Science Department, from the Multisensory Devices Group, and I have 3 different hats. Usually I'm a professor at the university. I'm also Deputy Director for Digital Health at the UCL Institute of Healthcare Engineering, as well as co-founder and CSO of a company on digital smell technology. So Orestes, if you could go to the next slide, please. That's going to be an interesting collaboration. I feel a little bit less sensory autonomy, I feel. So the whole area of my research is around touch taste, and smell. So you will hear a little bit more about those particular integration of sensory elements, but also particularly what the different kind of underlying principles or concepts are. But I would like to start with the next slide with a short video that hopefully gets you back from your nice coffee break and gets your attention. Why are we just communicating through a display and through sound? I mean, why are virtual remote spaces odorless? Why is there no touch integrated? But what we've seen in the last decade is an explosion of new technologies and computational power, which really allows us now to bring maybe haptic devices and olfactory devices in our homes. So in the future, I can actually smell, and I cannot just use my imagination, and maybe I can even taste it.
The smell is a black pepper, essential oil.
So that's really, and I love that ending, although it's a cut. If you go to the next slide, it's like it gives that idea that humans bring so much more into this relationship with technology and how we interact with the world around us. And what I try to do over the last now 1-2 decades already is trying to understand what touch, taste, and smell experiences can be designed for, and also how. And I think AI is quite an interesting turning point, because maybe there are considerations in the design of experiences that are taken away more from the human and go more into AI-generated experiences. So if you go to the next slide, Orestes, what I like to do is in the following slide to really walk you through some examples, and you find an overview of some of the research, the concept and ideas on multisensory experiences in the book Carlos Velasco and I have published. But what I really want to kind of emphasize here is particularly, if you go to the next slide, some of the key elements of what multisensory experiences are. And I promise this is the only definition I'm going to share, but I think we spent several months trying to actually get it right. So don't tell me now it's wrong, but I mean, obviously I'm open for discussion. But basically what we see as multisensory experiences are impressions formed by specific events whose sensory elements have been carefully crafted by someone. So for example, to create the impression of a sunflower, colors, shapes, textures, smells are considered, and the senses are placed at the center of the formation of the impression of the sunflower, even in the absence of a real flower. And especially the even is quite important, because that emphasizes the technological advancements that we can create those multisensory experiences now through those different multisensory technologies. So if you go to the next slide and we take that a bit apart, some of the questions one may ask is like why, what, when, how, who, and whom. And if you click again, Orestes, there are the kind of like related aspects of what's the rationale, what's the reason, why do we do it? What are the impressions? What is the specific event? How are the sensory elements combined? Who is it doing, the someone, and also the receiver. And I think that we take all of these questions and pick apart several examples in our book and in the research we have done. But what I would like to show you is a few examples now, but I want you all to think maybe about the why, the underlying rationale and the reason. Maybe pick also your own kind of research why you're doing certain things, but then also the who, the someone, who is the creator, who is the designer of the multisensory experience. So if you go to the next slide, or is this, let's skip that because you can find that in detail, and I'm happy to share that. But I want to demonstrate this example is one of the first where we integrated touch to experience art alongside smell and taste and sound and visual elements. But particularly here, if you click again, the Tate Sensorium, and if you click again, has augmented art in order to make art more accessible. At least that was the key premise, the key rationale when we worked with Tate Britain, with the art gallery, to say, well, typically you go in an art gallery and then it says, do not touch. So don't touch. I was like, we wanted to encourage that you actually touch. You can just smell art. You can taste art. Literally, we had a chocolatier working with us, integrating chocolate prompts into the visit of this particular exhibition. But also the what is, it's an immersive art experience. It was running over 6 weeks in the art gallery. We had the different sensory elements, as I mentioned, and who? It was Tate Britain who commissioned it through a competition, and then it was an interdisciplinary team with a variety of different experts, from sound designers to sensory designers, choreographers, art curators, but it was all led and coordinated by Flying Object, a kind of an art creative studio in London. And to whom? Well, it's the public, well, but particularly those who are visiting the art gallery. So again, it's very clear those different aspects. If you go to the next example, again, if you just click it quickly.
500 million dark matter particles every second are streaming through your body. Tonight, you'll be able to feel dark matter.
I'm afraid I can't give you the touch of dark matter tonight. So you have to kind of satisfy yourself with other pleasant experiences in France. But if you go to the next slide again and click one more time, again, if you think about why, this was particularly in context with a collaboration of our astrophysicists from the Imperial College, where it was embedded in science communication. How do we bring science closer to the wider public? How do we get people excited about the scientific investigations we are undertaking? And especially when it comes to astrophysics, a lot of the things are invisible to the eye, and also you can't touch them. And also, there are other kind of things which are missing, which we take so for granted when we explore our world every day and experience the world for all our senses, even if we are not always conscious about it. But here was really about creating some representation, a sensory representation of dark matter, together with this interdisciplinary team, and then we presented it to the wider public through the Science Museum, through an outreach event, in collaboration at that time with Sussex and Imperial College. So again, the interesting bit here was really about the use of it, the rationale, and engaging them to become more like open to scientific concepts, but also, and we heard earlier a talk about sensory substitutions and found as an opportunity to explore the world around us. And I think that is also a further context of this project, where we wanted to allow others to experience concepts through not just visual animations, but also through all their different senses, whatever sensory modalities are available to them. So again, that's a quite nice science-driven concept. If you go to the next one, that is an experience where we were involved together with a New York-based creative studio, New Reality, where we created Tree VR. Basically, is a multisensory virtual reality experience where you embody a tree. So you grow from underneath the earth up to a tall Peruvian tree. And it was supported by the Rainforest Alliance in order to make people aware about deforestation. So if you go to the next slide again, you can see that a lot of people suddenly became, well, quite literally, they put up their hands because every hand, and if you look at your hand, is a branch. So you could see yourself stretching out your arm, and the bird can basically sit on your arm, which is a branch, and you really embody this kind of 8 minutes, I think, almost 10 minutes experience. And it went around the world, including the World Economic Forum twice. It went to Dubai, it went to Singapore, to New York. So it has been kind of engaging a lot of people, including people who, a community of blind and visually impaired people who are typically excluded from virtual reality experience because we are very much kind of focusing on the breathtaking kind of visual and auditory elements. But if you just have sound, and then you enhance it through smell and touch. In this particular case, you have the subback on your backpack. So you feel the moment when something is hitting you as a trunk of a tree. But also, I don't want to give you a spoiler alert, but at the end, the tree is cut down by humans. So because it's about deforestation. So you smell the burning fire and you feel how you get hit till you die. So we had a lot of people actually who came out and said, okay, what can I do? And some people even cried and other people are unattached by it. So again, it's an interesting experience. And if you click again, we dissected again why. It's this awareness about deforestation. It's the life cycle of a tree in a first-person perspective. It's an installation in various public events across the globe. It has, I forgot wind as well, not just smell and touch and audiovisual. And also it was supported by an NGO, so Rainforest Alliance, and also the creators and the people who were providing the technology. And it aimed for everyone, but particularly in this case also policy and decision makers, because a lot of the politicians were actually at the World Economic Forum trying it out as well. If you go to the next one, which is my last example, again, it's a multisensory virtual reality experience led by Picture This Production, where we were involved. And it's a huge kind of like egg-shaped installation where you can go in and you have a motion platform, you have a seat there, and you can basically experience the evolution of flying. Where you can go back to Leonardo's kind of workshop and you can look around, and depending where you're looking, you get different smells and you get different kind of sensations. And then you can have the Wright brothers up to into the future of flying, what is imagined. This was supported by British Airways for the 100th anniversary. So if you click again, Orestes, okay, that's a short video. If we have time, we could quickly play that because I think it gives you a nice idea.
A young boy dreaming in the field, you actually felt you were right there with them.
Jeepers, really, you really feel like you're flying, it's super. I thought it was incredible. The platform, the wind, the temperature changes, all of that stuff just makes it so immersive. It was amazing.
It was really fun because when you were a bird, you could just fly really high and then you could just soar down.
Again, that gives an example of what a multisensory experience with different sensory elements could look like. And here the why, the rationale, as you can see, was very much the 100th anniversary of BA. But this experience of flying through time and space with a specific installation in the Saatchi Gallery in London, and then it went to Newcastle, and then lockdown happened. So unfortunately, the big egg didn't travel the world after that. But again, it was a collaboration between creatives and technology, and it was aimed to the wider public, the public who was interested also to go, the interested public, I guess, going to galleries and experiencing it. So if you go to the next slide, there are quite a few other experiences we have dissected in such a way, but what I like to kind of bring into this workshop a little bit as discussion is really the who is the someone, because I try to emphasize there's on one hand you have museums, art curators, but you also have like scientists and designers, developers who really want to kind of explore multisensory experiences. But then you start to have like more political motivated topics like deforestation and sustainability, where you bring in Rainforest Alliance, or now we worked with people who work with mushrooms and forest grounds. And then you have like companies like BA, which are obviously commercial oriented. So this someone is quite important. And if you click one more time, so what if in the future the someone is AI? And I mean, we don't even need to write future anymore, because AI is already doing it. If you even just try to ask ChatGPT to give you a multisensory narrative, I think it can already give you quite a nice narrative and story how it could look like. It doesn't give you all the details on how do you do it, and I think that is where a lot what AI might not be able to do. But it's an interesting question about this kind of someone, if it's not human anymore, what that might actually have as implications. And if you click to the next slide, so AI is only one part of the story, and I think that is also influencing a lot of other kind of technological advancements, like what we see in about humanoid robots. I was reading yesterday, I don't know if anyone saw it, that the University of Tokyo researcher have recreated the human skin, and they can make emotional expressions. I mean, it's in a very miniature form, and they can put this human skin on top of a robot to make them even more human-like. But anyway, that was just like an interesting article. But what if machines, not just humans or humans, were in charge of designing multisensory experiences, or in context of this workshop, haptic experiences in the future? What if machines could control what experiences we should have? For example, decide about what we eat and how we eat. If you think about food printing techniques, I mean, they could just say, oh, you didn't eat enough of that nutritional element, so let's put something extra in, although you might not be aware of it. Or when we give you some subtle sensory stimulations through touchless interactions or smells or other kind of stimulations. What if? And I think if you go to that next slide, there is in our final chapter, we talk critically about these responsibilities we have in designing multisensory experiences. And we kind of propose these 3 laws. And I'm sure many of you recognize there the 3 laws of robotics. And Asimov was obviously someone who inspired us. But we kind of like try to summarize that multisensory experiences should be used for good and must not harm others. Receivers of multisensory experiences must be treated fairly, and the someone and the sensory elements must be known. Well, everyone, I think, will say, well, obviously, this sounds very logical, and they are kept very simple in this high level, because it should kind of be easy to kind of like basically not do it. But if you read into the details, it's really about like, is it always clear what is good and what is not good? I mean, how do we know if we harm or if we don't harm? If you think about the active and passive touch discussion Patrick presented before, maybe we don't mean harm, but actually it harms us. And how does it harm us? And also, who is the receiver? Do we know that person, or do we not know the person? And what if we're designing only with the adult in mind, but actually children are experiencing an experience we have created or technology we have developed? and also the someone. I mean, if the someone is someone we know, someone we trust, it's fine. But what if the government is the someone? The government uses sensory elements to influence whatever, the next week election in the UK or the Euro 2024. What if we have bigger organizations with their own agenda and rationals, which are sitting in the background and actually using these multisensory experiences, technologies, and now also AI to create those experiences? So I think there's an interesting discussion to be had. But if you go to the next slide, and I think it's in my last one, that's what I really want to encourage. Let's discuss, and I know discussions and questions are best over coffee breaks and dinners, and that's why I apologize for not being there in person, but I hope I can still add something so you can discuss later as well. Thank you very much.
Thank you very much, Marianna. So if you have a question for Marianna.
Yes, please. At what point is a multisensory experience immersive enough to manipulate someone if she's talking about that? Like, what is smell optional, or like at what point would she see the critical point for being able to influence people in a bad regard?
Did you hear the question? Should I repeat?
I did. I think it's maybe if you want to stop sharing the screen, I don't know if that helps, but I don't think there is an easy answer on that, because I think what is important is to give people the control and the option to maybe switch something off. But I think we are very much aware about audiovisual stimulations these days, but we don't really know or have this kind of olfactory interface or haptic interface integrations in a wide range of our daily activities. So we might not even be aware that we are manipulated because we are actually enjoying this additional sensory stimulation. And a lot of the questions about when is it really manipulating is unclear, because we are still at the beginning of, especially when it comes to the chemosensory stimulation, at the beginning of building those interfaces and devices, but then also doing the experiments to understand what it actually what kind of perceptual effect it has. I don't know if it doesn't really answer your question, but I think it's a really important point to consider the kind of switch off button to be able to, like, I think, Patrick, you gave the example of you can close your eyes because you don't like the horror movie. So hopefully we can switch off some olfactory stimulation or some touch stimulation if we don't want it, but that requires us to actually be aware of that it's part of the experience.
Yeah, thank you very much. Sam, maybe one other question. Yes, please.
Part of that switching off, do you think it's because multisensory, should it come as a package, or should the user be able to control which sensory signal they want? Because I feel the challenge is per modality we could get good, but then the best experience are typically multisensorial, and then we use the other senses to kind of compensate for the shortcoming of one. But like for haptics, we use audio. We could use smell to evoke memory when the visual is not maybe sufficient. But then if you give the possibility of turning off, like you don't reach that multisensory goodness if people can pick and choose what they want in terms of sensory. So like, how do you see the control, like the designer or the someone designing these multisensory to say, oh, it's a bundle or nothing, or like, or how do you make it robust to keep it?
Because maybe changing one, switching, closing one,
yeah,
to change completely the experience. Marianna?
Really good question. I don't think I have thought about that in all its detail. What I can say is that I mean, we are exposed to multisensory stimuli all the time, and what comes through technological advancements is that we can have an intentionality That means we can have specific intention to create certain experiences with the aim of certain effects. And that's why it's so important to understand who is designing or what the underlying motivation is. Because if it is let's say my husband creates a multisensory birthday card for me, then I don't want to switch off certain things because there is an element of surprise and I want to experience it. But if the government wants to send me a multisensory, I don't know, election catalog, then I want to have the choice to switch it off because I know that certain sensory element might affect my behavior, my emotions, my decision making. So I think it's about transparency when we are designing multisensory experiences, and it also depends on what do you want to achieve, because I don't think multisensory technology is the answer and should be everywhere. I think we need to be carefully selecting when they should be used, and also then consider the human capabilities, because we have people with sensory impairment, people who can't see, who can't hear, can't smell, can't touch, or can't taste. So how can we then use also sensory substitution as an alternative way? But I think it's a step before that. We need to understand why they're doing it and who is doing it.
Great. Thank you very much. Let's thank again our speaker.
Thank you very much. Good afternoon, everyone. Thank you for joining our workshop today. My name is Iria Loucaidou. I am from Helix. Helix is one of the top 3 SMEs in Ireland in Horizon and Horizon Europe. And today I would like to talk to you about the Haptics and AI Helix and how these can enhance research and global collaboration in the fields of haptics and AI. So Haptics and AI Helix. Let me start by explaining what is the meaning behind the word Helix. Helix is an international collaboration group that is hosted on the Helix platform. We currently have more than 50 helixes in different and very diverse domains, as you can see. And each helix is basically a network of researchers in each field around the globe. So we're talking about universities, SMEs, startups, investors, and even corporate companies that are interested in taking some products or services into the market. Currently, we have these 4 relevant existing helixes: the Haptics Helix, the Trustworthy AI, Virtual Reality, and Digital. All these have more than 3,000 individual experts in total from 450 organizations around the globe. So I'm talking a lot about the network and the organizations. So let me say a bit more about this. Currently, we have 800 organizations, more than 800 organizations that are part of this platform, more than 15,000 individual members from 57 countries. This covers all EU member countries. Most of the third countries are associated with Horizon, like Turkey, Israel, Switzerland, Serbia, Canada, New Zealand. And some other countries, organizations from Asia and Africa. Here you can see some of the university members of the platform: CERN, UCL, KU Leuven, Cardiff, Bristol University, University of Cyprus, Aristotle University of Greece, Technical University of Denmark, Technical University of Munich, Utrecht University. So these are some examples of the members that we're talking about. Here are some of the corporate partners that are part of the platform and that you can collaborate with. So these are partners that are interested to take products and services into the market, like Huawei, Ericsson, IBM, Fujitsu, Boeing, Lexmark. And we also have a large number of companies that are part of the platform and are interested in forming collaborations. So currently on the Haptics Helix, we have more than 120 individual members from 100 organizations and 38 countries. You can see here the diversity of part of experts that are part of this community. And some of the members included in this community are UCL, Ultralip, University of Copenhagen, Eindhoven, University of Politécnica de Madrid, and University of Haifa. Here you can see the community of the AI Helix, more than 330 individual experts, 170 organizations from 44 countries. Some of the members include the Imperial College, University of Bristol, University of Turku, ITENER, Cyprus Institute, University of Twente, Ljubljana, and Ankara University. So here are some examples that I took from the platform today. So these are members of the platform, the ones that I just mentioned, that are seeking either to join a consortium or they are seeking for partners for a proposal that they're preparing. So users can basically post their ideas or reply to post and say that they're interested in joining a consortium. The platform, this Helix community are also designed to drive impact and promote key exploitable results of funded projects to relevant stakeholders. These are some of the posts I took from the Haptics and the virtual reality Helix. So currently we are project partners in more than 30 projects, EU-funded projects. We are impact acceleration partners. So we take care of impact that is sometimes neglected. And 4 of our current projects are focused on haptics, AI, VR, digital. Touchless project is one of the projects that is also will be in the exhibition of the conference. And also we organize a number of webinars and side events on these topics in order to help with matchmaking of global partners. And that's all for me. This is just the QR in case you would like to join the platform as an individual member. So.
We share some questions for Iria about the services, the impact. You know,
Well, I mean, we will be at the booth, the touchless booth, and Iria will be there to match make for any interested future consortium building or.
Yeah, so please look for the booth, and then you can contact them directly to get more information. Thank you very much again.
Okay, so let's get started with the panel discussion. So we have about 1 hour actually, and yeah, there's a lot of people that we can talk and we can have this more interactively, and we also have Marianna online as well, so she can hear us and she can talk, and it's also recorded.
I can.
Yeah, so how I plan to chair this this session is first we'll have some comments. Then we also opened up through the website. Actually, we had a form at the bottom where we could get questions from people on Twitter or LinkedIn, because we've been posting actively, and a few people have shared their questions. So I have 5 questions. So they are anonymous. So we did say that we would post them to the panel, so we will go through them, and I've shared them with the panel before. So, but we can reread them or kind of go through them again. So that's the plan, and we will also have participation and discussion, open discussion. So if you have something to say, just raise your hand and address anyone specifically, or if you want to just make a comment on one of the presentations, and then the people on the panel are quite friendly, so they will pick up that conversation. But so as I said, let's start with that. And the first thing I'd like to give the opportunity is basically to ask the organizers my co-organizers of today, so Iria, Claudio, and Justine, if they want to share that one or two things that really stand out from the five presentations of our expert speakers. So something that made an impression on you, or you will probably go away and think about or research. And what's the one thing that
how we want to think about how to use this very powerful tool in haptics, and now we want to, it seems that we are aware of the importance of understanding what we want to do and putting limits wherever they need to be put. So I think this kind of consciousness about the potential, but also the risks of using AI of haptics, and probably also AI in general, of course, I think it's very good for the community itself. So this was something that impresses me more than simply blindly going forward with this, also thinking about the effects of this technology for our community and also for the people that will experience our technology.
Justine, do you want to add something to that?
Yeah.
What was your...
Yeah, it was a bit the same like Claudio. Like we had very interesting discussion and more question about our research, not only the research of the panel. So it was very nice to have this question brings by Marianna, by Patrick, and everyone. Like, how can we apply them to our research, and what are the limits also? Yeah, it was a bit the same. And another thing that is more a comment, like I think we have very different speakers, but they met very well. It was a very nice workshop. A lot of people say that to me. So thank you for your presentation.
I think we can give a round of applause for the speakers with the stamp. Iria, do you want to say something? I mean, it's your first haptics conference, so what would you say?
Maybe it's not something that we really think about it to that extent, and that is something that made an impression.
I can say another thing that I like, since I like more than one thing. I think also the importance of multisensoriality. Right? So it's a haptics conference, but then it's very often we don't do only haptics. As we do haptics coupled with something else. Often it's vision, of course, but there are also many other senses involved. So it is important, I think, to recognize the importance of a well-rounded experience that transcends from what we are often used, that it's vision, audio at most, but to go a bit further through haptics. And again, even within haptics, not only vibrations, but other types of stimuli and the smell, of course, something that is a bit uncommon in our interactions, in our interaction with technology nowadays. So I think it's also something that stands out.
I feel like I'm vlogging or something by telling my hey. So to me, there was a yes, you're right. Our speakers were coming from different angles, but there was a lot of somehow there was cohesion on the messaging. I found really interesting the very strong and data-driven approach that Heather and Ercan have been taking in their research. So you're both using AI to expand the data sets, because you realize there's a limitation of and the cost of data harvesting or data generation. So those are really interesting ways of expanding that. It was really when Amir, you said 10 dB improvements in localization, I was like, okay, that's a big number, right? 10 dB immediately seeing that. So that was also something I'm going to look into. And I was you didn't really talk about it too much, but you more on a fundamental level, I was interested in how you said that how the brain seems to process haptic information, and how perhaps we can learn on how our brain works by looking at how AI learns. So that's you're kind of flipping it up around and saying, okay, let's not teach AI the way that we learn. Let's figure out how we learn by looking at how AI learns. Or at least that's how I interpreted your comment there. And perhaps if we expand that not only for haptics but multisensory as well, so that's an even bigger question. And of course, the ethics work, ethics of digital touch is something I'm also involved in. So I kind of expected I knew what Patrick was going to talk about, but of course that's fascinating and very important. So there was not one thing that made an impression. There was at least one thing from all of your talks that made an impression on me. So I would invite you, our speakers, to also say what made an impression on your fellow speakers and panelists, Amir, if you want to go first, something that stood out from the presentations because you're from a different field also, you're coming back to haptics.
Yeah, I think first on the personal level, I always had this tendency. I came from a vision training and vision lab, and I always felt like I'm studying these very strange topics, and there is no community with the haptics and with the multisensory. When we started it, we had 9 labs that were interested, and nobody, like Charles Spence from UK and some other. And there was even no session at Society for Neuroscience But one thing was I was amazed how much work and how high quality and how different disciplines like Marianna coming from computer science, or this network that I was not aware of. And so that's just on a personal level, it was very nice to see there is so much to learn and so much to. So I think I took a lot of notes and things to take, but one is we talked a little bit after with the coffee, but I think from the ethics discussions, it's a lot of things. We also in the GuestXR, which is a fellow consortium, had to deal a lot because it's even a social agent that use AI to moderate in VR space, and we just contribute the touch part of the virtual reality. But it's made me wonder, on one hand, sharpen how touch is different, and I think touch and movement is really so the comment on the self and how it's ingrained on us, and how dangerous it is on one hand, but on the other, how much potential there is there, because the impact of adding to vision and audition touch is enormous, and we are so behind on the actuators and the examples I gave. The 10dB was more on I rushed into the data, was more on the improving speech understanding.
Yes.
The localization was actually quicker and much more than 10dB. So the accuracy was there. So it's interesting how we take something like touch that in evolution we never used to localize things outside personal space. And if it's built on the computational principles of how the brain actually process localization, it can be very powerful. I'm not getting into all the other stuff. To personality here was amazing on emotions and on communication. So, and also the comment on the brain, actually my take was a little bit different, is by studying how the brain responds to doing the same task, like understanding geometry from the different senses, we can understand a little bit better how the brain is organized, not how AI can use this type of approach and add touch more into. It's not Patrick has Haggard has an amazing set of work on multisensory and touch and body perception and multisensory, but since the actuators were very difficult to get into the MRI machine traditionally, I think that the research is still very much behind. So that's another thing part of the reason, for example, that we try to make everything MRI compatible and now study the neuromechanism, so, and then integrate it with the other senses. So it's a very long answer, and I don't even remember the question, so I would start.
No, I think the question was what stood out from the presentations of the fellow expert, and I think you made some comments about a few things that you picked up. So who wants to go next? Maybe Ercan or Heather.
Was like a puzzle, and I liked very much each talk was a part of the puzzle. And important point is that exactly multimodality is most of us and Marianna pointed out, but at the same time, social inclusion. And particularly also at your talk, we can use haptics for social inclusion of the people who suffer from other senses. And of course, if we understand multimodal building of the perception, it is easier to understand also how should be haptics organized to fill these missing puzzle parts. And I think that this will be also in the future very important point. And another important point is that, of course, democratize the information transfer, because what I noticed that if I visit India, if I visit Africa, the information transfer is based on technology. You can have technology if you are rich, and this is a critical point worldwide. And if we can use AI for good aims, we can use cheap sensor and actuator technologies and make available also worldwide the information. This is also a critical point because in haptics we have incredible number of dimensions, and each dimension requires own sensor and also actuator, which makes very difficult to a comparison with visual domain, because if we think about camera, we have a picture and all information, color, size, and all other aspects are inside of it. This will be also a critical point in the development of AI applications, how we can develop universal actuator and sensor solutions together. These points.
Right. So on my side, what really stuck out to me was the emphasis on multimodal, because it really is important, because us in haptics, you know, when we do a lot of our tests, we blindfold people or, you know, play white noise in headphones, but we have this ability now with AI to really bring everything together, and we can actually build on, or we can actually, you know, build on the availability of data, because we don't have a lot of the haptic data, but we have a lot of visual and auditory data. So we could potentially, you know, use the multimodality to our advantage, because all of these senses are kind of interplaying together. So is there a way that we can kind of build on data from other senses as well, even if we're lacking within the haptic data domain, because that's really going to be one of our limiting factors. Another thing that really struck out to me, obviously, was the ethics, because I am really struck a lot with AI now, just because we can do something doesn't mean we should. And because I also work a lot in social touch, which unfortunately I didn't get to in the talk, and that has very, very serious ethical implications in terms of consent, in terms of the type of touch, in terms of, you know, age, and you know, and potential sexual assault. And so I had making sure that you include all of these ethics, not only in the, you know, not only within the type of, not only in the application, but in data usage, I think is going to be really, really important. So I really liked how kind of it got
the panel really covered, or the workshop really covered all different aspects that are really going to be so important to making sure that we have an effective use of AI within haptics, and make sure that because AI is so new within haptics, we have the potential of doing it right from the beginning, and we have the ability to police ourselves from the beginning rather than trying to correct after things go wrong, as we've seen in other fields.
Yeah, I find it really interesting because I don't really work in haptics. I certainly don't work in haptics engineering. So my day job is in somatosensory psychophysics and somatosensory neuroscience. So I learned a lot. Thank you very much. And I just want to make a couple of comments. So one is that it seems as though texture is the low-hanging fruit. That's the area where AI is going to change haptics fastest and possibly first, particularly in terms of generative. So in terms of a generative approach to AI and the ability to generate experiences, I thought texture was good, and that made me happy because at least for most texture perception, you can take your hand away. So it's kind of also, I think, safe because you're typically working on the fingertips. But I thought that there was an interesting reflection on texture perception. So we know that the frequency spectrum of the mechanical vibrations is extremely important for the experience you have. We know that it depends both on the receptors in the skin, but also on the skin mechanics. And we know that that changes with age. So you showed that, I think, very nice slide showing the drop off in the high frequency. And that's something which should be accessible to AI. So can we, for example, have frequency shift approaches to texture perception, where you can achieve texture perception which takes into account the individual transfer function of each person's skin? Can you allow people to develop particular sets of frequencies which provide useful texture perceptions for them? And can that be something which is perhaps inclusive for people of my age, in fact, even a bit less than my age, who are already apparently beginning to suffer a frequency drop-off? So I think there's some interesting room for inclusive AI on the frequency side in the texture space. The second comment I want to make is actually picking up on something that was in Marianna's really nice installations. I mean, these are things that people might actually pay to do. In some cases, there's corporate sponsored. In other cases, you presumably would pay, and that's probably coming. I think the multisensory art world is moving very fast. There are now a lot of interesting multisensory experiences. So the haptics part of these experiences is not yet immersive. So the immersive part comes from the vision and the sound. And your body is not really immersed. You might be getting some haptic stimulation through the seat. You might be getting some haptic stimulation through a moving platform, but we're not yet having immersive haptics. There are good reasons for that. It's risky. So if you start moving the whole body around with an exoskeleton or with these sorts of devices, then there's obviously a risk of hurting people. But I just wondered, perhaps this is a comment that other people can add to. Will we have truly immersive haptics, or will we use other sensors to generate the immersion and then add a little bit of haptic stimulation to the fingers or to the face as well? So is the haptics always going to be local and the sense of immersion in an environment going to come from other sensors? Or will we be able to make the haptic part also immersive? And I thought there it would be worth thinking a little bit more about thermal sensations, which, I mean, even from this room, we can tell that thermal sensations are all over your body, even when you don't want them. So thermal might be a way to get more immersive haptics. And of course, infrasound, which is another way that you can get full body sensations, possibly generated with AI guidance. So I'm really struck by this at the moment gap between where texture perception is. I think it's in a good, fast traveling place, and immersive experiences are also in a fast moving place, but they're not particularly haptic yet. Those are my comments.
Thank you, Patrick. Marianna, did you catch that? You did? Can I just say before I move to you, Marianna, just wanted to share also that, yeah, the textures has been a focus, and it's very much, you had this comment about whether we can put the personalized transfer function into the equation and train someone there. But and while a lot of the research in textures is on the properties of how they feel, there's also I guess a hedonic side to that. And so once you allow that into your personalized transfer function, then the ethics immediately becomes important, because it's not only about replication, it's also how does it make you feel, because maybe I have a preference on this particular material or this particular texture. It's something that I really like, and that's personal, while someone else may not like it. And so there's that aspect there as well. Marianna, would you like to say a few things as well?
Sure, I can. Going last is always the difficult part because everything smart has been said. I think first of all, I just want to say it was a really nice, US organizer did a really nice job in covering the whole spectrum. I felt we went so much into detail, especially the initial speakers did an amazing job in telling all the exciting bits, which around texture sensing and tactile sensing and synthesis and multi-model. And then towards the end, it became like a bit more open. So I think that was a really nice spectrum, and everything kind of links together. I don't know if you actually curated it like that or it just happened. So that always is something I'm curious about. Anyway, but I think I wanted to pick up on two things. One, what Heather was saying about that we are still in a really good position to shape, because the touch is quite early on. I mean, we're working a lot on touch and we are quite immersed in it. But if you're going into the wider public, well, people understand the vibrations of their mobile phones and maybe some other kind of integrations in gaming scenarios. But touch isn't that much present there yet, as obviously audiovisual technologies are. And so I think, if I understood you well, you really said that we have still a chance to influence. And I completely agree that that is what we should try to do, to kind of like help shape the field where it goes in, and I think linked very nicely with the responsible innovation approach, to anticipate some of the potential consequences there are, and maybe be able to avoid some of those consequences, although it's very difficult considering how rapidly AI is taking the world and is kind of changing a lot of the things we took so much for granted. And I think that is one thing where I think that there is a lot of discussion. So how do we shape it really so that it has an impact? What are the steps we have to take? The other thing, Patrick mentioned, immersive touch doesn't quite exist. So I just came back from Japan and I went to the team lab. I don't know if anyone has been in this, in a team lab. It's basically a huge space with multisensory experiences, and you walk through. And I saw the current show, which is on Borderless, and although it's visually and auditory extremely immersive, the one thing which I found super interesting, it's maybe not so much, well, it's touch and movement, because you can go to the walls, touch it, and what is on the wall is going to change. So based on your interaction, so people were started sitting in corners, and then suddenly the projection mapping, which was around them, changed. Suddenly, instead of flowers on the walls, you saw a waterfall or birds flying. Or when you were walking, you could start like swirling and dancing, and the floor is changing. So there is kind of I found that extremely immersive, and I was one of the few people next to the children running around like a crazy person. But it's those kind of things which are so exciting because they also show what you can do. And I agree, it's mostly in this immersive space, in the artistic space. But I think it's so powerful that we could think how we could change education, how we could change healthcare, where one of the big problem is people adhering to certain kind of rules to stay healthy and care for themselves, or in other kind of areas. So I think those, just as an example, that I think there are attempts towards this immersive touch experiences as well. I stop here because I think we still have a half an hour only.
Thank you, Marianna. We do have half an hour. Yes. So we had our initial discussions and points of interest by everyone. So then we have five. Actually, I just received a sixth question as well. So I'm gonna try. I've got them on the big screen, so you can read it, but also I can read it so you don't hurt your neck. And then after that, well, we can already have some interactive discussions as well. So the questions will be addressed to anyone in the panel who wants to take it, and anyone in the group, in the audience who wants to also comment on it. And I haven't actually curated them, so I don't know which one should go first. But so let's just take it from the top. So Marianna, can you see as well? Okay. Okay, so haptic technologies are varied, some targeting single element of touch, e.g. vibration or pressure or temperature, and some targeting different part of the body, face, hands, torso. When it comes to content creation, for example, immersive experiences or movie experiences, how do you see AI and hapticians working together or in opposition to port content from one haptic platform to another?
My impression is that also if we organize the experiments, the visual domain is very critical. Of course, if you cannot see or if you have visual impairment, it's a very different dimension. But if you can see, visual information plays a very strong role on the expectations. Therefore, it can be used in most cases as a reference to understand what is the plausible audio and haptic information for this visual information. And this helps all together because if you know it, you can differentiate, as I also discussed that, to different haptic stimulation and to different haptic dimensions. But first of all, as a reference, my impression is that visual information can be very helpful.
There's a lot of experiences in the world that are not visual first. Like if you ringtone or like typing on the keyboard, like there's stuff that are by design, not visual. And then we still have that challenge of porting experiences from one device or one system to another one. And that, like, there's no way to use a visual to inform what you should do.
This is actually the only question of the 6 or the 5 that I can answer or even talk about. So I'm going to jump right in if that's okay. So again, I'm just going to state the blindingly obvious. The answer to this question depends on the receptors, the neural receptors in the skin, which send signals to the brain, which are the basis of experience. So when you port something from one, let's say, actuator or one platform to another, a really critical question is, are the two platforms going to be stimulating the same receptors? So stimulating the fingertip will produce some experiences. If you port that to a platform where you might stimulate the whole arm, you've got a completely different set of receptors. You've got many fewer receptors. You're going to get different experiences and you're going to get less intense experiences. So I think there's a really important neuroscientific element to this question about the generalization of experiences across different devices and across different platforms, which is that it really helps to understand the receptor physiology. Different parts of the skin have different numbers of receptors distributed in different ways and with different distributions. So there are skin regions where primarily you've got higher frequency receptors and fewer low frequency receptors, for example. The distribution of thermal sensation, thermal receptors, is uneven across the skin surface. So this is all known. It's perhaps in rather dusty journals that we don't read as often as we should do. But I think the clever people who do receptor physiology in the somatosensory system have a lot of knowledge which can be used to select what sorts of platforms could be useful in the future for AI design of particular kinds of experiences that we want to offer people. So receptor physiology will really help with question one.
Do you think we can map that? Like,
No,
if you understand,
really-
you understand the mapping of receptor, you say we should be able to bridge.
There's a really interesting theory in neuroscience called the labeled line theory. So we talk a lot in VR and in haptics, we talk a lot about experience. So what is experience? It's actually quite difficult to understand experiences. I mean, I think we all have them, but it's quite difficult to understand them. And one of the theories about experiences says that all experiences have a small number of dimensions. They've almost all got intensity, so you can have more or less of an experience. There's a view which says all experiences have some valence, so no experience is really neutral. It's always a bit nice or a bit nasty. And the third one, which is perhaps the most elusive, is the idea of sensory quality. So here's a really interesting question. Why does seeing something seem so different from hearing it or touching it, given that in all three cases, it's just the same kind of neural impulse reaching your brain? Why do we have such different experiences from different sensory modalities? And there's no really good answer to that question, but there is a pseudo theory called the labeled line theory, which basically says that the different receptors in the body have some sort of little tag which they carry with their neural impulse, so that when the brain receives the neural impulse, it says, oh, that's a visual experience, or that's an auditory experience, that's a high frequency, low frequency, touch, pain, thermal. And labeled line theory basically is quite relevant to haptics design, because what it's saying is if you try to transfer an experience between two platforms, as long as the same receptors are present in both stimulations, then it'll work, it'll have the same quality. But if different receptors are present, it won't feel at all the same.
Yeah, my sense is that what the question seems to be alluding that AI is going to figure out a mapping that we never figured out.
So, yeah,
so
pretty good for that. Yeah.
So I'm just trying to figure out, are we waiting for AI to give us a solution that that we're struggling today, but we just need the scale or the speed or the power of AI, or we're looking for that golden answer that we don't even know, that we're not even capable of doing manually today in something like that.
So I think Ercan had a first, second.
Maybe as contra, if you look to film sound design or film design, you notice that the physics, if you represent the physics exactly the same, it doesn't function. This is same also at the laboratory. My point of view that because exactly we worked on it, we tried to measure physically absolutely correct and try to exactly create the same physiological reaction as possible. But the impression of the users or participants were always very disappointing. And if you look, for example, basketball play, and if you want to make a television, this basketball play, they use sounds which you cannot hear in this play. It means that ball sounds or sounds from the shoe, which are not really existent there if you as a watcher there, but at home, if you hear them, suddenly you feel that you are exactly there. Therefore, my point of view, we should define from these events maybe from visual domain, maybe also other emotional domains, which expectations we combine with this event or situation?
Yes, ma'am. Oh, I had so many things to comment, but I would limit myself. First of all, I think the thermal point is very interesting, and there is now a very interesting work limiting on testing how different emotional states from sadness, happiness, vision have a different feeling of activation in the body, and also that are very consistent across different people. It can be a visual representation, it can be a touch. So I think the comment on the thermal and also understanding really the physiology of the receptors could really help us. On the other hand, I have to completely disagree on the on stopping there, because I think, you know, like we discussed a little bit in the break, the input to the brain is a very small portion of the story. Yeah. So, for example, we used to think about vision if there is something that is getting inside our brain, and this is how we see, but we have 10 more times more connection from the eye to the first station that brings the information than input going to the brain. So it's the top-down modulation of vision, of touch, of sound that is much more important than the actual input from the receptors. So I think it's a very small part of the story. And I think immersion is like one example. So for example, we played with this stereo touch algorithm for space in VR context. And the immersion is quite incredible. And I think also, so yeah, you know, touch, vision, immersion is helpful, but vision is so bad in comparison to reality, even in VR with all the avatars and so on. So touch sound can be a very interesting direction. So again, I think there to your to your comment, we all the time wait for AI to solve the problem, and it will solve a lot of problems. But I gave one example. Maybe we were super lucky, yeah. But where the AI put all the power and but the model was wrong, like using this multiple array. Go to see how things are built in the brain. You know, if you want to do somatosensory, look on Patrick's 30, 40 years of work on how things represent, but don't stop with the receptor, of course. And once you have the model of how we immerse in space, our body in relation to the location in space, implement that, and now use the power of generative AI and all these big models and so on, the result, and again, maybe we're lucky, but was one order of magnitude higher than the benchmark. Okay? So it can work both ways, you know. Yeah, maybe the final comment, although I have many more, but I'm talking too much, is that we can think about actuators that have touch. Somatosensory in itself is multimodal, yeah. So we can have the actuators have several dimensions, you know, vibration, thermal, and so on. But then you can make the leap.
Yeah, that you have a comment. I think.
Yeah, so I want to bring in the engineering side in that these haptic devices generally are not standardized. And so a lot of them are created in the lab, a lot of them created one-off. So until we as a community agree on standards for devices or agree on a way to evaluate devices, both either whether it's a tactile or cutaneous device or whether it's a kinesthetic device, then it would be very, very challenging to say that if I have device A and I have device B and I have these, you know, and I have this signal on device A, I can make this transform and it's going to feel exactly the same on device B. So there really is going to need to be some type of either standardization or some method of evaluation, of device evaluation, that's going to be needed to be learned or fed into the AI before we can do this type of device to device mapping, regardless of what we know about the perception in the somatosensory systems.
So I have a very quick comment. I think one approach is to wait for this standardization. It will be a very long process, but another is that For example, we try to analyze what can the motors of the smartphone can give us in terms of haptic. Apparently, much more than we use. So we can use like up to like hundreds of hertz in there. So, you know, another approach, creative approach, we didn't do anything on this, but it could be interesting, is to say, okay, everybody uses smartphones and maybe a little bit VR more and more, and let's evaluate what's there and adapt what we are doing to this, and then we will have much more data and much more impact. And that's the quick comment.
So I think we've answered the first part of the first question.
How can we talk for?
We have, So we have, and I know Marianna wants to comment as well, but maybe I can move to the second part of the first question and question 2.
Organize the conference and not
which I'll get the AI to do that for me. So, Marianna, is it okay if we move to the second part of the first question and the second question where there's a strong multimodal component, and you can take the first part there? And maybe
I think actually somehow my comment fit that puzzle of the second part. So you might be in luck. Otherwise, just stop me. I think what I wanted to just quickly comment on the discussions, because I agree with my colleagues there. I think understanding the receptor part is important, but we should not forget about the subjective element of the experience. And I think that is where AI could actually be quite useful to optimize the specific experience to the individual who is receiving it. Because we know that it depends on your emotional state, it depends on your prior experiences, it depends on so many other factors if you're alone or where you are and so on. So I think that is where be really useful as a collaborator to fine-tune and optimize an experience for the specific target user. And I think some of the concepts, at least what we're using in our field in human-computer interaction, look at the temporal, the spatial, and the semantic congruency. So when you're trying to integrate the different sensory elements, then you need to understand, well, how does touch work? You touch and you feel it. Smell has a different temporal diffusion and a different kind of time frame. So you need to start synchronizing those kind of elements spatially, temporal, but also then semantics. And I think semantic congruency is really a key point for user experience designers for multimodal experiences, because in the end of the day, it's all about the particular story you're telling to bring everything together. And yes, there are differences in devices, there are differences in receptors, but I think you should try to stick to some common ground and principles. But then on top of that, there is variability. And I think that is also then open to us humans still to be creative, because one of the things I learned over the last decade working with all these creators and artists in the different kind of examples I showed is that certain things you can define, and then there is uncertainty. And I think that is where the expertise of us humans still come in, where AI can be someone to help, reflect, maybe give you some suggestions, but AI, I don't think is clever enough to kind of like find the final solution for it. So I just wanted to kind of like emphasize the fact of AI is more a collaborator, enabler, rather than we outsource it to the AI. And one area where I think we still need to do more is this human AI alignment, especially when it comes to sensory perception, because AI can talk a lot about visual and maybe even auditory sensory perception. But when it comes to touch, when you ask them, and that's something we are doing right now in the lab, ask them to describe fabrics or different tactile sensation, the alignment between human and the AI is actually quite bad. So just to add that to the conversation.
Sorry, can I ask a question, Marianna? Can you say what the direction of the misalignment is? Can you give some examples of what sort of errors
So we
there
all-
are between AI judgment and human judgment.
So we only started
In vision,
doing
that
that.
turns out to be really interesting. So in understanding the kinds of errors that artificial vision AIs have made in, for example, object recognition or scene recognition tasks, that turns out to be an extremely interesting scientific insight into the alignment problem. Now I'll let you answer, sorry.
Yeah, so as I said, we only started looking into that and doing some trial where it's really when you, I mean, we look at fabric, so, and it's like we all base it on descriptions and verbal expressions, and they are very much kind of referring to other sensory elements. So we're using a lot of cross-model associations in order to describe the softness or the roughness of certain fabrics, and that's where the human, I think, is very good in discriminating certain kind of like tactile sensations. But when it comes to just using the descriptions, the AI wasn't able to kind of create that alignment where humans were able to do. I don't know if it makes sense, because I can actually physical touch. AI cannot touch it. Only relies on the descriptors, which are either available to the AI, to the algorithm, or what we feed into it to help kind of like based on the taxonomy we develop in order to help it to maybe make the discrimination between different fabric choices clearer. I don't know if that answers.
I think maybe just a quick comment. It's very interesting discussion is that I think AI is really good at okay, maybe vision, but also mainly on language. Like there is so much data on language, on text, on words, on and the point you two raise is that there are some aspects of our experience that are very difficult to map between like object. Okay, this is a chair and this is a chair. It's very easy, but there is some aspects of our existence, and touch is one of them, that it's difficult to come up with the right words, and there maybe this is a source of misalignment. And I think in general, like AI is, the example you gave on texture is actually very different from a lot of AI I saw in machine learning, is that it's so heavily rely on these language models, and language is just one very late thing in our development in our existence. So that might be another source of misalignment.
So
and that's where experience comes in a lot, right? Even though it's difficult to define.
Yeah. Since we have very heated discussion, and we have, I think we touched now on question 2 as well. So maybe we have questions 3, 4, and 5, and I don't know which one the audience wants to hear answered or addressed. I don't know if you can read it. We make it big, and then perhaps the audience can vote by show of hands if they like question 3, 4, or 5. So question 3 is about kind of Hollywood and AI, risk of jobs. Question 4 is about perhaps more generative approach. And question 5 has to do with media haptics, and also whether AI could design haptics in a similar way. So people who like question 3, hands up. People who like question 4, hands up. And people who like question 5, hands up. Okay, so I think the winner is question 4 for now, and then we do question 5, and if there's time, we do question 3. So question 4 was, we all have tried the website that transforms a series of keywords into the billboard of a Disney-like movie. How would the equivalent look like for haptics? So keywords and then a haptic billboard. Experts? Any comments?
So what I'm thinking this is getting at is, the user would describe the feeling of something that they want to feel, and then the AI would generate something that feels like I want the simple would be I want a vibration sensation that feels exciting, or I want a texture that feels soft, or something like that. So that kind of gets back to what we were talking about at the end of the last question, then would be needing to have the match between language and haptics, needing to, you to be able to describe something and then having it generate an equivalent haptic sensation. So that would be needing to have that kind of correlation between what we verbalize or what we create meaning into something, and then what would be the corresponding haptic sensation for it.
Would you expect some particular medium for haptics? Would it be so what would be the haptic platform of your choice for a haptic billboard or a haptic AI billboard?
Does that have to be billboard?
It's an example.
More
That's what it
like
says.
just a haptic sensation in general, like a generative AI haptic sensation. But we're thinking like, is billboards tough because it's quite large. Yeah, I would think either for this I would do either something like vibration sensation. So you could do vibration sensation in the phone. Like I want the vibration sensation to feel exciting or welcoming, or even something like irritating. Or you could even do it like a robot motion. You could even do like social touch. Like I want to create a robot motion that is welcoming, or I want to create a robot hug that is welcoming or loving or calming. And so it really depends. I could see this being, applicable to so many different types of haptics. It just whether you have the data that could make the correlation between what comes down to labels. So whether you have the data that can make the correlation between your natural language labels, like how we would describe them, and the haptic data.
We are a bit limited by the platforms, right? Because not everyone has a very expensive, nice grounded haptic interface or whatever we need. So what you're saying, everybody has a phone, and the phones you have nowadays very good and better vibrotactile motor. So maybe this can be a good start, right? Before moving to phones or other platforms that can provide richer feedback. So we show the need and the richness that this kind of haptic sensations can provide to our experience with technology and interaction with technology. Then we can move forward.
Also, a billboard is kind of a broadcast medium, and so through the phones are also broadcast in some sense, if you consent to their. Okay, we can try and do the last one, I guess, as well. So question 5. So we all know that media haptics can make shapes that float, and for many years we have added transducers and developed algorithms to make them smoother and more precise. But this accuracy is in the eye of the beholder. Would an AI do the same? So I feel this is an AI haptic engineer. Would they have done the same approach of making things more accurate in a similar sense?
How I can know that this sensation will feel smoother?
How would an AI know?
To a human, right?
It's the first big question, yeah.
Because you want the human to interact with it, right? We don't want the AI to enjoy the interaction, right? So it should devise something that then feels good for the human, hopefully.
I don't think so. It is not, as we told, that it is very complicated aspects, haptics individually, because of the multidimensional aspects. And at the same time, AI can be helpful, as Marianna also said, us to find easy solutions and to analyze incredible number of data. But this data is not existing already in haptic domain, which means that we should create, first of all, this data. We should create labeling. And if everything is there, AI can deliver individual solutions and help us. But I don't think that AI can take over all this expertise. But we will see.
Wasim?
Then I put a little twist on this question and frame it this way. How can we guide AI to help us navigate complex design spaces to create meaningful experiences?
Actually, therefore, in my talk, I would like to concentrate on labeling, because as expertise, we can give keywords to the AI, because as also Marianna said, that AI needs data. And if we can say that this data is relevant, but these all are not relevant, then we give a good way for AI to analyze and give good decisions.
Categorize, let's say it's very good.
Exactly.
Categorizing.
Can I just ask where will the labels come from? Will we have thousands of exploited workers doing haptic labeling tasks for years in order to train the AIs? That seems a bit unfair. So, I mean, the LLMs were trained because there were big databases that were there and available. How are we going to train these models? I think it's important.
Can I tell a little story about this? I sat down with the professor in my former university, and he had a startup called Mobileye that was sold later in 13 billion, and he created these semi-autonomic cars models, and that's exactly what they do. Like, so the basic model was not that genius in terms of the algorithm. They decided to take, like, hire in Sri Lanka, like 400 people that sat down in this and did very quickly all the labeling and solve it. So maybe it is one that the industry will go. Yeah. But I think where it becomes very interesting, the labeling issue, is this alignment between emotion and the higher order, like feelings and touch. And we all know about this story about these babies that develop without touch. They have terrible problems. So touch is really key in this. And I want to give one very quick example, which I found the best paper I read in many, many years, not from my lab. And it's really intriguing. And just to give an example where AI can be really helpful, I think, if we think about it a little bit different, and also put the brain and the person in the center. So the paper, basically what it did is, through some, I won't get into the technical details, but elevated the activity level dramatically in two brain structures called ventral tegmental area and nucleus accumbens, okay? And they studied it on mice that have cancer. And they showed that elevating this reward system, the system that, allows to feel good or to learn and so on and so forth, can reduce in 50% tumors in a few weeks following this elevation. And they're very well controlled, published in Cell and so on. So I think where it could be really interesting is that if we will tag somehow what drives us to feel rewarded, and then have all this big data set, and then you go back and see which tactile sensation, for example, tactile I think can be multisensory, but actually is the key, I think. Maybe also smell and taste, but it's, and then it can start saying, okay, this is my, maybe now it start giving us predictions when we have this big data set that map between experiences or sensory and reward like labels. And I think also it can be dramatic in terms of medicine. Yeah, just this example of cancer is one, but there is many cases, autoimmune diseases, mental, and so on, that this could be like really important in making medicine better.
So I think we are out of time. Thank you for the story sharing, Amir, and very ambitious also to try and through haptics and AI, there's an opportunity of possibility of addressing serious problems like cancer. So thanks everyone for joining. Let's all thank the speakers who stayed and were extremely engaged. We really turned on the heat on them. So, and we have a great next few days over the conference. Thanks a lot.
I could say one last word. Thank you two a lot.
Thank you,
because
special to Obrist.
People don't aware, but they did a lot of work behind and sent us questions and nagged us and then the forums, and so it did it. I think it was successful because we put the work and the brain.
Especially thanks to Obrist for leading this effort.
It was a team effort, so thank you.